Okay, so part two, I split it because it was going to get too long. We're dealing with rational numbers as exponents now. And I tried to write everything out to save time. X to the 1 over n, they're going to get fancy and try to confuse us with the way they write this. But we can think of it reverse. We can think of it this way. X to the 1 over n equals the n root of x to the first power. I wrote my little hint over here to help you make sense. Probably should have switched my m and my n so n matched up with numerator, but our index over here becomes our denominator. And then this exponent is whatever our numerator was. So when we're rewriting these, we can switch them any way we want. We can move things around and get an exponent or a variable raised to a fraction exponent with a numerator denominator, or we can get that fraction set up and move it to this way, whichever is easiest. So examples 10 through 14, we have 8 to the 1/3. It just means here's our denominator. It becomes our index. Denominator becomes the index. So cubed root of 8, that's 2. 36 to the 1/2. Just a minute, Finn. My 2.5-year-old wants in. She loves math. So 36 to the 1/2, that becomes square root of 36. There's my denominator, becomes my index. Now, negative 25 to the 1/2, when we get an issue like this, again, remember that negative is just saying negative whatever this amount is. And I can do that. I just keep this negative following along, or leading the way since it's in the beginning, but it just follows along with this. So I can have the square root of 25, and I can negate it. Square root of 25 is 5, negate it is negative 5, and then down here gives us the other case. When we have the whole quantity raised, that means we're trying to take this root of this amount. Well, when this amount is negative, we don't have a real number because it's inside the parentheses. We put everything under here. Here's our denominator, becomes our index. This whole piece becomes our quantity underneath, and we can't have a square root of a negative. Now, one other that I waited to put up here is just fraction form. I know there's a lot of my students that don't like fractions. I don't think of them as fractions. When you get something like this, they're saying square root of whatever you have. Well, I have 4/9. Still a fraction, but if you don't like fractions, all you have to do is think of this as square root of 4 over square root of 9. You know the square root of 4 is 2. You know square root of 9 is 3. There's your answer. It's a fraction. You don't have to think of it as a fraction. When you get something like this, apply the exponent to each piece. Apply it to the numerator, apply it to the denominator. This is how, like, the technical process that we think of. But when you see it, you can just say, oh, what's the square root of that? What's the square root of that? And think of it as a 4 and a 9 instead of a 4/9. Okay, let's get rid of this stuff and move on, and we'll blow through some of these. There's a ton of them. I'm just going to have to pick and choose which ones we do. We'll do it. Just start with example 15 and work from there. So they want you to write with a rational exponent and then simplify. Now you're going to see some of these they're just using as examples to help us understand. This one would be much easier to just do, but they want us to write it out. So my index becomes my denominator, and then for this case, I'm going to raise this entire thing to 1/3. Once I do that, the other route you can, well, let's just go with this for now, because I think that's the route the book goes. Yeah, this is the route the book goes. The book now splits this, and they probably use parentheses at first. All right, so they get us this. X to the 6th to the 1/3. We use our exponent rules throughout this whole chapter. Just stick with your exponent rules. X to the 6th raised to the 1/3, y to the 12th raised to the 1/3. And then we move down, and you know that when you have an exponent raised to an exponent, you're multiplying. So it's x to the 6/3, y to the 12/3. I know that's a jump that some students will ask questions about. I'm just taking x to the 6/1 times 1/3 equals x to the 6/3. That's what they're doing with it. Once you get that, you know that x to the 6/3 becomes y, x squared, y to the 12/3 becomes y to the 4th. You could have done that up here. The thought process is what we did in part 1 when we took 6 divided by 3 is 2. Well, 6 times 1/3 is 6 divided by 3. 12 divided by 3 is 4. Well, 12 times 1/3 is 12 divided by 3. So the thought process, we're just laying out in fraction form with exponents over here instead of doing our simple division. This is much easier for this one right here. Some of them might be easier to do in the fraction for an exponent form. All right, let's do a few more. Just takes practice. We'll do example 18. Example 18, simplify as much as possible. That's what their directions say. Simplify as much as possible. This denominator becomes my index. I'll write it in this case so we can see it. Becomes my index. Now, you're going to see that it's often easier to write in fraction form, because right now, if I take this, I have 25 cubed. So if I write this thinking this route, I have 25 to the 3/2 becomes the square root of 25 cubed. Well, that's a pretty big number. It actually gives us, let me look so I don't have to do it again. Gives us 15,625 for an answer, and the square root of that is our 125. However, what they'll want us to do in this case is think of it this way. I have a half times 3/1. I can even write this out. We could say 25 3/1 times 1/2. Well, I can apply that half and say 25 to the 1/2 cubed. When I do that, I know that 25 to the 1/2 is square root of 25. I've really flipped the way I'm doing this. I'm taking the square root first and then I'm cubing. So 25 to the 1/2 raised to the 3rd power, or cubed, gives me 5 cubed. 5 cubed equals 125 is a much simpler way to do this. So on some of these, you're just going to mix and match, kind of choose the easiest method. When it comes test time, I don't really care which method I'm not going to force you to do one. I just want you to simplify and get the answer. So you'll want to pick the easiest route. Now, let's go to example 19. I think this is another one that might be easier to keep in fraction. Yeah, this one's easier to keep in fraction form. Now they give us 9 raised to the negative 3/2. Well, I can take 9 to the 1/2 raised to the negative 3. I can split this up any way I want to. But if the key is, I know what 9 to the 1/2 is. I know what the square root of 9 is. When I take 9 to the 1/2, I know that's 3. When I raise to a negative exponent, again, I know that all that means is I put it on the bottom, or I do the reciprocal. So if it's a whole number, I just put it on under 1. So 1 over 3 cubed is 1 over 27. We can do it the other route, but we get a nasty number that we have to deal with before we can finally try and whittle it down. So in this case, split it up. Pull something out that you know if you see it. I know the square root of 9 is 3, so I'm going to take 9 to the 1/2 because it's a value. 9 to the 1/2 is square root of 9, which is 3. It's a value. I just pulled a value out, and I'm raising that to -3. So easier to keep this in fraction form. That's why they taught us how to do it. If they give us, example 20 is pretty much the same thing, but they give us a fraction. Example 20 gives us 27 over 8 raised to the -4/3. Well, I'm going to take, we'll do it this way. We'll do it this way, just so you can see everything. I know there's a cube root to 27. I know there's a cube root to 8. Those are the two most popular ones that'll pop up in this section. So I'm going to go ahead and pull my 1/3 out. When I pull my 1/3 out, you can flip them at any time, but when I pull my 1/3 out, then I know I have 27 to the 1/3 is the cubed root of 27. 8 to the 1/3 is the cubed root of 8. So I took the cubed root of 27 because 27 to the 1/3, cubed root of 8 because 8 to the 1/3. That's how I got 3 and 2. Now, again, when you have a negative with fractions, the easiest way to think of these is to just flip it. You can think 3 to the -4th, 2 to the -4th, what do I have to do? Or anytime you see a fraction raised to a negative exponent, just flip them. So now we get 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 times 3 is 9, times 3 is 27, times 3 is 81. 16 over 81 for example 20. Now let's try and squeeze a few more in here. Because they're going to shift to multiplication and then ask us to simplify after we multiply. I'm going to have to get some water before I make my 6.2 video. My voice is slipping. Example 21. They give us x to the 1/3 times x to the 5/6. Again, when we multiply variables with exponents, we add the exponents. To add fractions, I'll do this over here. To add fractions, we need the LCD. We need the same denominator. How do we make 3 equal to 6? We multiply by 2, so we do that at the top. 2 6. You can see 2 divided by 2 is 1, 6 divided by 2 is 3. So what we really have is x to the 2/6 plus 5/6. So we have x to the 7/6, which is goofy looking and it's improper, but in algebra we don't care. We leave it as an improper fraction because we want a fraction answer as opposed to a decimal or a mixed number of some sort. Now what we can do is take this and rewrite it to make it cleaner, or if that's what they ask for. I know that that is my index. The denominator is my index. Whatever's left, my numerator, that's the power. So I'm dealing with x to the 7th, and I'm taking the 6th root of it. Example 22. They give us y to the 2/3 times, or raised to 3/4. When we have a power raised to a power, That's when we multiply. Multiplication much easier than addition. 2/3 raised to 3/4. So we multiply the two exponents. By doing so, 3 goes into 3 once, 2 goes into itself once, it goes into 4 twice, y to the 1/2. We can rewrite that as square root of y. So much easier when we get to multiply. The addition, when we're in fractions, addition is the difficult part. Multiplication, division, easy stuff. Okay, example, that's division. Hopefully you remember division. We're going to skip that. We're going to go example 24. Example 24 gives us a to the negative 1/3 divided by b to the 1/2 all over 6. Now, it depends on what you see and what you catch. There might be a time when you have a variable here, the same variable in the numerator and denominator raised to a power. It might be easier to do this and then raise it to the 6th power. But we're dealing with different variables. So right now we're going to I'll take an extra step. We have that on the top. Negative 1/3 raised to the 6th power is times 6 over 1. I have b to the 1/2 raised to the 6th power, so I multiply by 6 over 1. What happens is I can cross cancel, it's much easier. So I get 2, but it's a negative, a to the negative 2. And over here, my 2 divides evenly, and I have b cubed. What I have to do is if you have a positive variable or positive exponent, leave it. Leave the variable where it is. If you have a negative exponent, that's when you have to move it. Remember, it's easier to just think move it. Wherever it is, move it to the other side. So I leave my 1 because I'm dropping this down. And this is 1 over b cubed regardless. We know that. When I have a to the negative 2, that becomes 1 over a squared. That's why I need to hold that 1. I need the 1 in the numerator because this is 1 over b cubed. To make that a positive, I need to put it under 1. And I move it down here to make it positive. So I have 1 over b cubed, a squared. Then they just give us, example 25 gives us a bigger one to deal with, but it's the same process. So I'm not going to bore you with that. We're at 18 minutes already. So that's part 2, the rational numbers as exponents. Again, let me know if you have specific questions regarding the problem sets. Hope you're having fun.